We now have our last part of this video, and that's the power equation. The power equation says that power equals work divided by time. So now we're familiar with most of these terms. We've talked about the term work earlier in this video that was measured in joules, and we've talked about time several times before as being measured in seconds, but that introduces us to the new concept of power. Power is the rate at which energy is transferred. Now, most of the time we say that that's power equals work divided by time, but it could actually be any sort of energy divided by time. One of the most common misconceptions about power is that it is somehow some type of energy, and it's not. It's the rate at which energy is used. So a lot of people say, oh, well, the electricity company is the power company. And they're not the power company because they're not selling you power. What they're doing is they're selling you energy. Specifically, they're selling you electrical energy, but they're selling you energy, not power. So that's kind of an incorrect term or misnomer for who provides you electricity. So let's take a look at this equation in action. It says, what is the power of a weightlifter who lifts a 200 kilogram barbell 1.2 meters above their head? The weightlifter is 1.7 meters tall and completes the lift in 0.75 seconds. So let's take a look at this. We are trying to solve for the power. We have a 200 kilogram barbell, 1.2 meters above their head, 1.7 meters tall, and completes it in 0.75 seconds. So let's go ahead and take a look at this question. We say, okay, I'm trying to solve for power, and I'm given mass of 200 kilograms. I'm given a distance of 1.2 meters. I'm given another distance of 1.7 meters, and then I'm given a time of 0.75 seconds. Now, the equation that I have for power is power equals work over time. One of the problems with this in this particular case is that I don't actually have work. I have time, but I can't calculate power from just time. So instead what I want to do is I want to expand this equation. So instead of work, I want to put force times distance over time. And that gives me a new equation. It gets me a little bit closer because I have a distance term. In fact, I've got two of them. I've got to figure out what to do with that, but not quite yet. So now I've got this force equals distance over time, but still, once again, I don't actually have force. So let's expand it a little bit further because remember, force is really mass times acceleration. So what that can give me is power equals mass times acceleration times distance divided by time. Okay, and you look at this and you say, okay, well, I've got mass, I've got distance, and I've got time, but I'm still missing acceleration. But what you need to do is you need to think about it. They're lifting the weight vertically. Whenever you lift it vertically, remember your acceleration due to gravity comes into play, and you know the acceleration due to gravity is 9.8 meters per second squared. So, because of that, you can now say, okay, power is equal to, we like to say that physics has the power to make you mad over time. It's the easy way to remember it. But now we come back to this idea of I have two distances. Remember, what am I trying to solve for? I'm trying to figure out the power from picking it up off the ground all the way over his head. So the fact that he's a certain height shouldn't matter, and the fact that he lifts it a certain distance over his head doesn't matter. I actually need the combination of those two for a total of 2.9 meters. So when I do that, I can now plug in my numbers. I can say, okay, power or the mass is 200, the acceleration is 9.8, the distance is 2.9, and we can divide it by the time, which is 0.75 seconds. Now when you take all those and you combine them, you end up getting something pretty large. It should be about 7,580 watts is what you should get. So you need to be able to take the power equation and expand the work, expand the force, and get it to what you need to be. And that's probably the trickiest thing that you can do with these energy and power equations, is that you have to expand them. The second example says, how much force is exerted by a 1200 watt engine, so I'm looking for force, by a 1200 watt engine that lifts an object 5 meters in 2.4 seconds. So we're trying to solve for force. We have the power of an object being 1200 watts. And this is something that's confusing for people sometimes because they say, well, wait a second, Is that work because it's 1200 W? Remember, 1200 watts is the unit of power. If it was measured in joules, then it would be a unit of energy, so it could be work. So you've got to know those units in order to distinguish between these. You have the object is lifted a total of 5 meters, and the time is 2.4 seconds. When you take these three variables, you can now go ahead and figure out what your equation is. My equation is power equals work over time. And once again, you'll see that that doesn't actually have force in it. So what I need to do is I need to expand the equation to force times distance over time. Oh, excuse me, force times distance over time. Because work, remember, is force times distance. Now if you were to take a look at it, I've got power, which is what which I've got right here. I've got distance, I've got time, which means the only thing that I don't have is force, which is what I'm trying to solve for. So you can go ahead and say power equals force times distance over time. We can now plug in. We would say 1200 equals force times 5 divided by 2.4. You would multiply both sides by 2.4. You would divide both sides by 5. And when you did that, you would get an answer of 576 newtons. The last example we have says determine the time required for a 60-watt light bulb. Determine the time for a 60-watt light bulb to give off 50,000 joules of energy. So we are trying to solve for time. And I have a 60-watt light bulb, so that means I'm given the power. I'm given an energy of 50,000 joules. Now remember, it can be work or it can be any other type of energy. In this case, it's probably a combination of light and heat, and that allows me to solve for time. I use the equation P equals W over T, or 60 equals 50,000 divided by T. You would multiply both sides by T to get it to the other side. Now, a lot of people want to divide by 50,000 there. You can't do that because remember, you would have T on the bottom at that point. So you multiply both sides by T, and then you divide both sides by 60. And now what you have is you have T equals 50,000 over 60, which is 833 seconds.